my name is Dave Garacci. Some of you I know, some of you I don't know, but I'm happy that you're here. I have been doing 3D printing now for about 10 years. I started with a basic sort of FDM printer that most other people have started with, and eventually worked my way into resin, which is a little higher quality in some cases. My background is architecture. I work as an architectural illustrator. I run my own company, and I put together 3D models, renderings, and animation for architects and developers around the state and sort of in the region. One of the nice things about knowing 3D modeling and doing some 3D illustration was that it led right into 3D modeling for 3D printing. So when I first saw my first 3D printers was at MSOE, Milwaukee School of Engineering in Milwaukee, obviously. And at that point, they had 3 or 4 really nice but very large printers. We sat down a couple of days and looked at the equipment. We had a breakdown of how it works and some of the costs and other issues that might, there we go. Some of the costs or other issues that might arise. And I thought to myself, wow, wouldn't it be cool to be able to take some of the games that I've been working on and actually print out these miniatures. I've always been a miniatures guy. Since I was a kid, I was into playing with little spaceships or soldiers or whatever, and trying to turn that playtime into a game. And when I saw these 3D printers, I was like, wow, I can take some of these ideas I have, maybe take some of the sketches I've drawn, and actually turn those into a figure or something that I can play with. All right, so again, I've got a company called Polygon Forge. That's the architectural rendering company, but we also do 3D models there. And then my hobby business is Tactical Game Systems. And Tactical Game Systems is where I do game design. It's where I do 3D modeling. It's where I do 3D printing for people. We do custom 3D printing, so if somebody has a model already, we can print that for you as a prototype. We don't do large-scale manufacturing. I don't print more than a couple of them for you. But it helps people when they're working on games, or you can also take that 3D print and make copies of that with molding materials if you're into that. I run an Elego Mars print farm, which is basically all resin printers. Anycubic is the same kind of printer as an Elego, so if you've heard of those 2 printer types, they're the same. Let's see here. So, a couple of questions. Who has done 3D printing? Okay. Who has had someone do 3D printing for them? All right. And is there anybody here who doesn't understand the very basic concept of what a 3D print is? So basically what I'm trying to do is figure out how many of these slides I can skim over as we're doing this presentation so we don't run out of time. So every object in our world has 3 axes. X and Y go side to side, or front to back, and Z is up and down, okay? And that's, again, I think everybody sort of understands that. When we're doing 3D printing, we need that information, those 3 coordinates, to be able to create the objects that we want to create. Whether it's the X and Y dimensions, which give you sort of the shape or the outline of the object you're building, or the Z dimension, which gives you the height. As you can see in this graphic down at the bottom, you've got a cube. We've broken it down into 10 layers, or Z layers, sometimes called slices. And then we put that on a plate and sort of are representing how those layers are going to get stacked on top of one another. Now, there are 2 main types of printing. There's FDM printing, which is fused deposition modeling, and that's where you get a plastic spool of filament and you feed that into a print head that's heated, melts the plastic, and then you place that plastic on a flat plate, and as that first layer dries, you start to put new melted plastic on top of it until it finally builds up into a solid object. And again, we'll get into that detail a little more next. So there's also resin printing, where you have a vat of material. It's like a liquid resin that you are going to solidify or cure using light. In some cases, it's a laser light. It's very precise. In other cases, it's a projector light, very similar to the projector we have right here, just turned on its back or on its bottom and focusing up onto a glass plate. Light, whether it's a laser light or light from a projector, will solidify the goo inside of that vat, and then we'll start to create those slices again that we talked about. Our goal here is to create an object additively that's structurally sound. So as we're printing it and as we're playing with it, it's not going to fall apart, it's not going to bend or become too brittle where it breaks when we touch it. Most printers are going to print the object in a series of layers, and we call these layers slices. The slices could be anywhere from 1 or 2 millimeters thick, which is pretty large, down to like 10 or 20 microns, which is like 0.01 millimeters. So that's pretty thin. Once you get down below 0.025 millimeter, it's really hard to see the lines, at least with us, most people's vision. You get a magnifying glass, obviously you can start to zoom in and see that. You can see in this graphic here that with a resin printer, you're printing upside down. On an FDM printer, we're printing sort of top or from the bottom up. With a resin printer, the print is upside down and it's built as the plate goes into the goo, and as it starts to rise up, new layers are created. So when you're done, you've got this print up on the top of your printer, all finished with this resin dripping off of it into the tray. This is an example more of FDM style printer. You can see there's STL, or the file that we use to create these objects are called STLs. Those go into a slicer, which is another piece of software that is used to break down those Z layers and create the outline of the shapes that we want. And then you can see it goes to the printer, and the printer squirts the melted resin out onto the various layers as they're built. Here's another example of what some of those slices might look like. This was a game piece that I worked on. It's supposed to be a military base. And the form factor is circular, sort of a hemisphere, but it has some structural pieces around the edge. Again, here's my architecture size showing up a little bit, where you've got these little columns that you can see as you're running through the different layers. So if you start on the upper left corner, and we work our way over to the right, you'll see the first layer, that bottom layer, is just a circle. The next layer is a sort of radial shape with a circle in the middle and then these columns around the outside. As we start to get higher and higher up on the object, we go down on the right side here, you can see more circle as the roof starts to show up. And then finally, way at the top, we have sort of a spire. So there are a lot of other layers here. You're only seeing 5 of them. There's probably 1,000 layers in that shape. And I'm just kind of skipping to every, 150 or 200 layers. But you can see those shapes, when you're printing with resin, your projector or your laser is projecting that light, that white shape, into the resin tray. And that white area is what's going to solidify layer by layer into an object. When you're doing FDM printing, you use the same sort of technique, but instead of solidifying that layer, or that Z section one layer at a time, it is tracing out that shape and infilling that circle. I know I could start drawing some stuff over there, but I told them before, if I start drawing, I may not stop, and I may never get through this presentation. So here's another example. This is a little harder to see there, but so there's a figure that someone jumped on Hero Forge and created, and then we brought it into Cura, which is the software I use to do the printing. And at the bottom of the print, you can see there's a circle. That's the base of the print. And then if you go off to the right, you can see as we rise up a little bit, and then we see the skirt area. We go back down, and now we start to see a torso and a little bit of the wings starting to show up. And as we work our way over and down, you see more wings, and eventually just the head and a little bit of the top of one of the wings. So again, these slices are what creates the shape. Certain objects are much more difficult to create because of this. If you have objects, and we talked about this a little before, JT and I did, if you have a person, for example, that you are trying to print out, and he's got arms sticking out like this, when you try to print that without any kind of supports or anything to hold up the arms, when they get printed, they're just going to fall apart. They're just going to fall down into the plate or into the resin. So what you need to do, if you have something with a couple of swords or whatever, is put some supports onto those objects so that when they print, they don't fall apart. Now, I don't have a picture of that in this particular slice image, but we do have some examples of that there, and I'll show you some photos of what I mean by the support structure that you're going to need for that. Okay, and then finally in this sort of intro, you can see on the right side we have 2 images. At the top it says 10 millimeters on each one, so you get an idea of how big that is. It's about 1 centimeter. And this is one of the prints. I don't have the black one here, but this is one of the models that I created and printed there, so you'll be able to look at it closer when we're done with this. But if you look at those images on the left side, towards the middle of that spaceship image, you'll see a little square that kind of bumps out a little bit. Let me see if I can show you right over here. And if you look at that little shape, you can see that there's about 10 lines or 10 layers that make up that element. If you look over to the right, where we've doubled the resolution or we've reduced the thickness of the Z layers in half, you can see that there's like 20 little lines. But the lines are a lot smaller and they're harder to see. You can also tell that the panel lines or the edges of that object are much more refined on the right side than they are on the left side. Now again, this is the same type of printer with just 2 different resolutions for the Z depth, but you can see how much difference it makes once you increase that. The downside, of course, of increasing slices is that it starts to take a lot longer. So the print at 1 millimeter or 0.1 millimeter takes half as long as the print at 0.05 millimeter. And that's just something to sort of keep in mind. Or I should say half as long. Yeah, half as long. In the lower left corner, you can see 2 different types of prints, and they're both sitting on the table, so we'll look at those in a little bit. The one on the bottom is an FDM style print. The one on the right is a resin print. Again, same model, just printed on 2 different printers, and you get a sort of different style and a different look. All right, did that make sense? I know that was kind of quick, but does everybody sort of understand what we're talking about as far as slices and layers go? All right. Next, we're going to talk about the different types of printers. Also, we're going to check the time. All right. So the first style, and it's the one that most people are familiar with, is FDM, or fused deposition modeling. Sometimes that's called fused filament fabrication. And there's a legal reason for that, but we're not going to get into that right now. You can look it up. These are the plastic spool-based printers that use a filament, and there's a wide variety of filaments. PLA is the one that most people use, and that's a light plastic. It's pretty solid and not very brittle, but it does a pretty good job with getting smaller details. You can also print with ABS. You can also print with wood. You can print with metal. There's a number of different filaments out there. It's important when you use those to read up about the filament and check out the sort of makeup, chemical makeup of that, to make sure that what you're printing isn't a little dangerous. And what I mean by that is, if you have a printer set up on your desk and you're printing constantly, it's probably going to be fine unless you're printing with like a metal filament, in which case you might be melting metal and there might be some fumes coming off. So just something to keep in mind. There's a lot of filament types out there. These are great for doing larger objects like terrain pieces. They're also good for miniature designs, especially in the early stages, the kind of things that we like to do. Rough game design. More and more, these printers are getting to a point where the resolution and the detail is very, very tight. And it's starting to get to the point where it's almost as good as some of the resin printers that are out there. It's sometimes hard to tell for me when I look at an image on screen what type of printer it is. But once you feel it, you can tell the difference, because usually the resin is a little heavier than the PLA. I know GameCrafter is now offering FDM-style printed minis for you to use in your games. They look great, they feel great, and I would definitely suggest, especially due to the cost, is JT in here? I don't want him to hear me say this, but the cost is really good. Like these minis are cheap, so if you want to get some, get them now and get a bunch of them. It's just really nice to be able to sit down at, he's got a whole bag of them over there. It's nice to be able to sit down at Protospiel or sit down at one of your monthly game design meetings and be able to actually have miniatures there. Cardboard counters are great. I use a lot of them. They're not going away anytime soon. But every once in a while, it's cool to have something special. Maybe there's a special counter you have, and that's the one that is 3D printed. Maybe that's the first player counter or something, and that's got to be a little special. So to get in a little more detail about it, but not too much because we don't have a lot of time, the filament is fed through a tube that goes into a metal print head. That print head is heated up to maybe 200 centigrade. Again, it depends on the type of filament you use. PLA is a lower heat to melt it, whereas if you're using ABS or some of the higher end filaments, you might be looking at 220 or 240 degrees Celsius. Sometimes this is considered to be less expensive type of printing, sometimes that's true, but there are some other options out there that are similar to FDM printing, like the PolyJet printers, where you're looking at $100,000 for this type of printer. So now those are really nice. They're super fast. The quality is great. But again, that's more of an industrial use, and probably not something that you guys would jump on. But like I said before, you can buy parts for an FDM printer, or you can buy an FDM printer for $100 or $200. They're not that expensive. And there's a couple on the side there. We'll talk a little bit more about specific printers when we get a little further along. Again, you can see a very large printer on the left side. That graphic didn't show up very well, but that thing is 10 feet long. Also, this type of technology can be used for other things. It's being used to build buildings as well. Here's an example in Dubai of a company that made a really giant FDM printer, basically, and they're using it to create the walls for these buildings. Now, contractors aren't going to go out of business anytime soon because you still have to do all the carpentry and the electrical and the plumbing and all that other stuff we need. But in certain situations, and especially in certain areas of the world where they don't have lots of supplies, where it's more expensive to get some of these materials, they can use this kind of technology and just basically like the dirt and water that's in the area and some lime and start to create walls for a building. So cool and sort of a neat thing that's going on. So how does this help us as game designers? So you can see, game pieces. Here's a couple of different FDM game pieces. One is one of my spaceships. Another is a guy on Thingiverse created some dice that he wanted, a certain color, a certain size. You can see in the middle there are a lot of 3D Kickstarters out there where you can go to Kickstarter or some other crowdfunding platform and get yourself some very nice STLs. In this case, these were the pirate ships. The hull down at the bottom was 3D printed, and then the stuff on the top that's very organic looking, the balloon part of those ships, were created with sort of the standard process of paper mache or whatever. I don't exactly. I think maybe they're foam. Maybe they were hard foam that he carved. But again, you can see it's not just 3D printing. You take the 3D printer, you can add things to the objects. It doesn't have to just be from the 3D printer. Look at it as a base. Up in the upper right corner, you can see one of the Game Crafter's wizard pawns. Very nice detail. It's kind of funny because if you compare one of those to one of my old FDM prints, they look like two completely different worlds. I mean, it's crazy. And then in the lower right corner, you can see somebody made a marker, some oil drums that they can use in their game for whatever it is that they needed to use them for. But what's nice about that, and it's kind of hard to see, I don't have a way to zoom into that, but when they printed those, they aligned it so that the striations or the layer lines that you see on the print actually are lined up with the barrels. So the barrel looks ribbed, like it has these little lines on it, and like it's supposed to look that way. So you don't have to go in there later and sand it down or paint it with some sort of material. There's, we'll talk about that in a second. There's a lot of options out there. Here's another guy that's been doing a lot of 3D printing for gaming. You can see he's got some aircraft, he's got tanks, he did a really nice big building. Again, FDM printing is nice for things like that because you can print fairly large size objects and the texture that you get, whereas on a miniature, maybe you want to get rid of that texture, but on a building, the texture is actually kind of nice because it adds some 3D depth to the walls and roof or whatever. Here we go. Okay, so that was FDM printing. The next style is SLS, and that's selective laser sintering. Now this has been around for a long time. The downside of this type of printing is that it's very expensive. It's very accurate. You're able to use different materials to create objects that have the the factors that you want in that material can be tested much better with an SLS printer. Another downside of this type of printing, though, is that it's very porous on the surface of the material. And if we jump down for a second here, it's kind of hard to see here, but there's at least one example on the table where the types of objects that you can create with this type of printing are awesome. Part of the reason is because they're printed in a vat of powder. So if you can imagine, like a bag of flour dumped into a big bucket, the laser for this type of printer shoots through that material at a certain power. It starts to cure or solidify the object. As it's doing that, the powder or the material below the print holds up the print as it's being created. So you don't need supports. If you were to put a person in that printer or a model of a person in that printer, as you were printing the arms, the pellets or the material underneath it would hold up that arm for you, so you don't need to put in supports. Again, the downside is this is another one of those industrial design type of machines where you're looking at least $20,000 or $40,000 to get started with something like this. And it's probably more than what we need for the kind of things that we do. So I had a hard time finding miniatures using this technology because it's expensive and there's not a lot of people doing it right now. But you can see there is a die there in the lower right corner that was created, and it's kind of cool because those numbers are sort of stretching into the inside of the shape of the die. But again, it has sort of a rough texture to it, which isn't necessarily the best for what we want to do. Okay, and then we get to SLA. SLA is the type of printing that I do for the most part. It's been around for 20 to 30 years, but it's really only in the last maybe 10 years that it's gotten to a point where we as consumers can start to use it and afford it. There are three types of SLA printing. There's laser SLA, which is like the Formlabs style of printers. There is DLP, which means direct light projection, and that was one of the ones that had been out for a while. It's a simple way of 3D printing because basically you're just using a projector and projecting one of those images that I showed you before onto the plate. And it's kind of coming back now in a different form. The third type is masked SLA or MSLA, and that's what you would find in most of the resin printers that are coming out now, which is the Elegoo printers or the Anycubic printers. There's a liquid material inside of the vat. As that object is created, you'll see there's a metal plate that goes down into the vat of liquid. Light shines up and solidifies that material, and then that plate moves up so that more resin can go underneath where the print was just made. Then the plate goes back down. It keeps doing that up and down. What's important with resin printing is that the liquid stays liquefied. So you want a nice warm printing room, like 74, 75 degrees. If the resin gets too cold, it starts to move slowly. And then as that plate comes down to create the next layer, not enough resin gets underneath it, and you end up with failures. So if you are going to do resin printing, there's some things you need to concern yourself with in the environment. We'll talk about that in a little bit. One of the downsides of this printing is these objects, much like FDM, they have visible striations or lines that you can see in the print. Depending on how much time you have or the type of material you're using, those lines could start to disappear a little bit if you spend more time and use thinner lines. You can also purchase paint or primer. Smooth On makes a primer called XTC, which is a rubbery sort of paint. You paint it on the surface of the object, it starts to fill in those gaps, and then you're able to go in and sand that down after it hardens to get a smoother print. A lot of people that do costume design, where there's masks and things like that, they use that material to help smooth out their 3D prints. Let's see. So with SLS or SLA printing, you've got a number of different resins. You can use ABS resin if you want a really hard object that's not going to break when you drop it on a table. You can use flexible resins. We got an example of that up there where it's definitely not going to drop. And in fact, you can throw it across the room and it's not going to drop or not going to break. But there are some downsides. ABS resin and other specialty resins tend to smell or off-gas a little more than the basic resins. And if you're the kind of person that works in your print room, if you have an office set up with a printer next to you, that might get to be a little bit of a problem. So if you are going to print with these more specialized resins, you want to keep that in mind and maybe do a little research on what it's made out of and how that might affect you if you're sensitive to fumes and that type of thing. This is used by engineers and dentists. When you get a cap or a filling, I think it's a cap made, this is the type of technology they use to make that tooth that they then create a mold of to put in your mouth. You don't want to put the resin in your mouth. In most cases, this resin is not safe for human consumption. You don't want to use it to make like a glass or something. You can do that with FDM printing because PLA is totally safe. This, not so much. Again, with this type of printing, you need support materials. You need to be able to hold up these objects that are kind of hanging off in space so they don't fail when you're printing. And then down at the bottom, there's a little graphic that shows the three different types. One uses mirrors and a laser. The downside of that really is keeping the laser clean, keeping the mirrors clean. Because any bit of dust on that mirror is going to make a hole in your print. And yes, that happened to me many times. I decided to take my printers and move them out of my workshop because it just wasn't a good thing to be trying to work on even just styrene models or cardboard and have that dust in the air. It would get inside the printer somehow, and then my prints would fail. So another thing to keep in mind. Nice thing about this is that the cost is low for the quality that you get. For $200 or $300, you can get a really nice resin printer, and the quality looks almost as nice, I'm not going to say as nice, but almost as nice as the $3,000 laser SLA printer. It just depends on what you need and what you're looking for. So here's some more examples of prints. These are SLA prints. Some of these were done at Shapeways, and some of these were done by the creator. And you can see up on the top, those are a couple of Shapeways models, and down at the bottom, or I should say over on the left corner there, who organized this slide? So upper left corner is Shapeways, upper right corner is Shapeways, and lower right corner is Shapeways. And then the one on the left side is one he printed himself on his own Elegoo Pro. And it looks great. I mean, the little gun barrels, they're so tiny. Like, you kind of expect that not to even show up, but we're getting to the point now with this technology that you can have that kind of detail. So let's see here. These are some of my prints. You can see some tanks in the upper left corner for miniatures game. The two painted miniatures were sent off a few years ago to clients to have them paint those for me to use in marketing. So obviously the prints don't come out that way. They were painted. The one in the lower right corner, that's just a straight print. I do a lot of spaceships. I do a lot of armored vehicles. I do a lot of hard surface type of objects. I don't do a lot of people. I don't do a lot of fighters with weapons or things like that. For me, with my architecture background, I'm into these hard surfaces. But organic modeling is a little harder as well. With a program like FormZ or something like that, you can definitely do it though. Here you can see on the upper left corner there is a Formlabs printer, and there's the plate that I keep talking about. That's the black element up on the top there. You can see some prints attached to it down at the bottom, and then you can see the orange resin tray below that with the white resin inside of it. As the printer plate moves up and down, it keeps dipping those prints into the resin. You can see on the lower left corner there is a print, and you can see that support structure I talked about. Somebody asked me earlier, what angle did you print that piece on? And angle is really important for resin printing because if you print it flat on the plate, certain objects that need supports won't be able to have supports and they might fail. Also, with flatter shapes, if you have a horizontal shape that's sort of flat, parallel to the ground, you're going to see the layers a lot more when you look at those shapes as it builds up than if they're tilted a little bit, because when they're at an angle, they sort of stretch out a little bit. It smooths it out automatically. You can see some game pieces I made for a motorcycle racing game or a bike racing game I was working on, a monocycle racing game, and then another APC type miniature there. All right, and then the last one we're going to talk about on printers is CLIP, or continuous liquid interface production, or sometimes called digital continuous liquid forming. Right now there's only 2 companies that I know of in the world that have printers that can do this. One of them is from Australia. They sell their printers for about 20 grand. In addition to that, they almost require, I guess they don't require it. I had heard they required it, but somebody else said, oh no, they don't. Another $20,000 for the support plan per year. Okay, so if something goes wrong with this printer, you're out of luck. You gotta send it back for them to fix it. Now, another company has just come out. I thought I was done with this presentation about 2 weeks ago, and I was going through my Facebook feed, and sure enough, somebody else has just come out with a new printer called the Rocket One, which does a very similar thing. It's slightly different, but the point is, it prints continuously. So you don't have this plate going up and down. You don't have the FDM printer head moving around all over the place. You just have a vat of liquid, and this plate slowly moves out of the vat. And miniatures that would take maybe an hour to print only take about 10 minutes to print. And this new printer is going to sell for $600
Oh, wow.
instead of $20,000 or $40,000. Now, it's not out yet. So, this may be one of those things where, hey, we got this out, and it ends up not being so great, but I'm definitely interested. And anybody that wants to be able to print fairly quickly should probably look into this. It's one of those things where 10 years from now, we'll probably all have this type of printer. But right now, it's on the cutting edge, as it were. So, All right, so before we get into benefits here, did that make sense? Does anybody have any questions about the different types of printers and benefits or drawbacks of using those printers at this point? Okay, so the next thing we're going to talk about are the direct benefits for us as game designers. What are some of the things that we can do with this? Well, one of them obviously is tokens. You can do all kinds of tokens. We can make barrels, we can make cubes, we can make bricks. You know, when you find out that you can't get that one token that you want, you can jump on the internet, like Thingiverse or one of the other free modeling sites, find an object and print it. I tried to go through and label where these things came from, and there's links to some of these as well to go to the guy's site if you want to try to download them. But you can see on the left side there, he's got a number of different elements that you can download and use in your game. And it's a pack. You download that and you have all of those. And it's free. You can see in the middle there, one of my favorite miniatures recently is the weird Cthulhu-looking thing that you can get at the Game Crafter. That's another FDM print, which, like I said before, looks really nice. It's a fairly smooth print, and it's a very cool, shape and design. And then over on the right, just some other tokens I've done. I did a piece for a game. I don't remember what the game was called now. It was another board game. I did a little skull for that. And then just some other ideas. Every once in a while, somebody will say to me, hey, it'd be cool to have this thing to do this in my board game. And so I'll just go into 3D and I'll start to make some stuff. Little tiny image in the upper right corner, that's supposed to be a shield. You would put your figure inside of that, and that's supposed to be like a protective shield that he's cast. Down at the bottom there, there's a little flame or sort of a exploding mass of plasma, whatever that is. Or maybe just, again, like I said before, maybe specialized tokens. You can do the +1, +2 cardboard tokens if you want, or try something in 3D. It makes your game stand out. Okay, so next, game dice. A lot of people have specialized dice that they want to do. In the Game Crafter, you can get different types of dice with images on them. There's a lot of cool stuff you can do. In this case, you might come up with something that, uses a special image that you want to emboss onto the die. You can see in the lower left corner, I worked on a game. It was a pirate board game, and he wanted a die for wind direction. So we took a regular 6-sided die, and we just changed up the faces so that they had wind directions instead of numbers. Then we printed that on the resin printer, which is one of those things where for dice, you probably want a resin printer. An FDM printer may not be a tight enough print for the shape or the design that you want to make. Or again, it just depends on the printer and how much time and money you have for that. But you can see in the upper right corner, that's an FDM print that somebody made where they took the 1 for the dice and they made it into this weird mouth with teeth and a tongue sticking out. But the quality of that looks pretty good. And again, that's another free model you could download if you wanted to, or have someone model that for you. In the lower right corner, you can see a specialized die that someone made that has Braille on it. And I've printed a couple of those for friends. It's a great file. It prints great, whether it's FDM or resin. Although if you do want to print it in FDM, the bottom face gets to be a little tricky because it's flat on the plate. So, dice. Meeples. Here's a case where whether it's pawns or other elements that you use in your game, you've got a lot you can do. Whether it's going online to download something, whether it's calling a friend and saying, hey, can you 3D model this thing for me? Once you get the model, you can do a lot with it. Whether it's change the size, change the color, a lot of cool things you can do. So I wanted to showcase Eric's game here, Second Babel, because Eric was in a situation where he had this game put together, it was working, things were great, and he suddenly couldn't get one of the pieces he needed for the game. So instead of being able to, or instead of just sort of giving up and saying, either I'm going to pay a bunch of extra money to get these in plastic or whatever, he was able to say, you know what, I'm just going to do this myself. Get some free software or some inexpensive software, use some basic shapes, because again, his game uses basic shapes, so it's not like he needs to model a lot of stuff in detail, although I really like the way the pawns turned out. But those blocks that you see initially were cubes, wooden cubes that had to be glued together to make those different shapes. Now he can just print the whole shape at once, and he gets his different sizes that he needs. Those wooden cubes weren't available anymore, so he was able to basically do this on his own with his own 3D printer. And I'm not sure about this. Eric could tell you, he doesn't have a lot of 3D modeling skills. So he was able to put this together, and it looks great. I've played the game. I love the game. The pieces feel good. You know, they don't feel too light. They have a little bit of texture to them, but that's actually kind of cool. You know. So again, a great example of what you can do with the elements and the tools and resources that we have. Up in the upper right corner, you can see some of the game pieces that I've worked on. Again, they're tanks, hovercraft, that type of thing. And again, I try to keep them small so that they can be placed on a board. This is more for board games, not for miniatures, tabletop gaming, but I do that as well. Below that, you can see some of the pawns for the Game Crafter, and we've got a couple on the table there. These, again, are great pieces, awesome for early game design stages, and the quality is spectacular. And then down in the lower right corner, you can see there's another miniatures. It looks like some sort of Cthulhu thing. But Delvingwood is a company that does 3D printing, custom 3D printing for people as well. And they have their own projects, like terrain and dungeon type projects that they're working on. So next would be game accessories, and this sort of plays off of those as well. Like, you can't get the base anymore for the piece that you used. You can just print your own base. You want to put a dice tower in your game, either download one or make your own dice tower and print it out. A lot of times I'll have people come to me and ask for elements to use in their RPG games. We've got a room and we want some chairs and tables and stuff. If you go online and look for those as like a HO scale model or whatever, they get to be kind of expensive. But here's a case where somebody can model that for you. Probably won't take more than a half hour to an hour to build that shape, and then send it to you, and then you can print that. And because they're so small, they print fairly quickly. Those shelves in the lower right corner, I think it took 30 minutes to print 6 or 10 of those. And in that case, I actually put little books on there and everything. So the guy who got them, all he had to do was just paint each book a slightly different color or whatever. It ended up looking kind of cool. So, all right. So 2 more of these. Product development. Obviously, you're able to build your own stuff, which is going to help your game progress in the way you want it to go. So you don't necessarily have to use the only thing you could find. You can come up with your own design. You can come up with your own shape, use whatever materials you want to, and then if you're working on your game, and let's say you can only get the 9, I'm trying to remember all the board sizes that you guys have, but let's say you can only get like the 9x18 board or something. Maybe that's not one. Maybe your piece is too big for that board, or maybe it's too small. The nice thing about 3D printing is you can iterate. You can go in there and make it a little larger, print it, and see what it looks like. Try 3 different sizes. Which one looks best? Bring it to the game design meeting and ask the people that you're sitting down with to play test, what do you think of this piece? Which one do you like best? It's a little dangerous because you can iterate too much, especially when you get to the end of your design phase, and it's just like, oh, I just want that sword to be a little bit longer, or I wish that the base for that piece was a little thicker. And you can end up with like a pile of 20 prints, before you have the one that you finally like. But if you've got the time and the money, it's definitely worth it. The thing I love about it is being able to go to Protospiel, being able to go to crowdfunding events and show people what you have. Like, this is the actual miniature I'm going to use in my game. And again, I love the Game Crafter and everything it offers, but you get to a certain point, especially towards the end of your game design, where you might want to be more specific about what you're going to show to a publisher or distributor or whatever. I've got 2 games that I've worked on recently that used my 3D printed parts. Solar War, which I've been working on for years, and Maximum Effort, which is a World War II style game. But I couldn't find miniatures for that World War II game that were quite the right size. The Axis and Ally stuff looked pretty good, but it wasn't quite right. So I ended up making my own and printing some of my own stuff for that game. Okay, finally on this section here, a lot of people ask me, can I use these 3D models for final production? Like, if I get my game to a point where I'm going to publish it, it's going to get produced, whether it's here or overseas, can I take these 3D models that you've built for me or that someone has built for me, and can I use them for plastic injection molding? And the answer is yes and no. In some cases, some companies can take that STL file that we talked about and use that to create the plastic miniatures. They may do that by actually using the file you sent them, or they may use it by taking that file and converting it into another program that they can use to create the plastic injected piece. Because as most of you probably know, a model for 3D printing is a completely different model than for plastic injection molding. They're two different processes. In one case, you can take a solid object and just print that whole thing. With plastic injected molding, you need to break those parts down into moldable or injectable pieces. And I'm not going to get into the whole plastic injection process because that could be a whole separate seminar. It'd be great to have somebody come and do that kind of seminar in the future maybe. But what you can do, which is kind of nice, well, let me step back for a second. You can take that model that you've built and send it to Panda or Long Pack, and they will use that. Either they'll give that to their artist to say, hey, this is what we need, or they'll take that and bring it into like SolidWorks or one of the higher end 3D programs where they can test and see where the plastic that's injected goes in the mold. And they can decide, okay, well, you know what, we got to do the arms separately. We can't do them all as one shape. So we're going to have to glue those on before we send them out or whatever. So just something to keep in mind. One of the nice things, though, is with especially the resin prints, you can take those and then use a smooth-on style rubber mold material to make your own molds, and then use a 2-part resin to pour into the mold to create copies of that. So you don't have to spend a lot of time 3D printing 20 pieces. Maybe just print one, and then spend the time to make the mold, and you can just make your own copies of it as you go. Again, there's chemicals involved, and that's a little higher end process for some people, but I've done it before, and it's not that bad. It just takes a little ramping up to learn how to do it. Okay, so any questions about benefits? Any ideas anybody had that they want to talk about briefly? We will have some question time, hopefully, if I keep moving fast. All right. Things to consider. Cost. You can get 3D printers now for $200. You can buy a kit to make your own FDM printer for less. Obviously, you get what you pay for. And a $200 printer is not going to be as good as the $600 printer. It's going to be close, though. Nowadays, it's going to be really close. But you're going to be able to print faster and print more as you start to spend a little more money. You also need to take into account all the additional costs that go with printing. Now, with FDM printing, there's not as much. You still might need to add supports. You still may need to have some cleanup, where you need to buy some clippers to cut off the supports. You may want to get some sandpaper or a little Dremel tool to go in and clean things off and smooth out your prints. Obviously, the cost of the filament is important. Right now, filament, for what you get, it's sort of like filament to resin. Filament's about half the cost of resin. Okay, and ignore the pricing there. I'm just can I cover that up so JT doesn't see that? But again, it's about 2 to 3 times as much to print with resin as it is to print with FDM. But we're talking fairly small amounts usually. You're going to need to buy curing equipment for your resin printer, and basically what that is a curing box that emits light at a certain wavelength that will cure any liquid resin still on your print. And it'll solidify the print that's been made to a hardness that you want. So if you take a print, put it in the the UV box, and let the light run for 2 minutes, it's not going to be as hard as if you let the light run for 4 minutes. Now, with certain types of manufacturing, they change the amount of time that light hits the object so that it represents the material or the object that they want to prototype very accurately. For us, we usually just want it to be really hard so that it doesn't break when we drop it on the table. But you can go too far sometimes, and the resin will get super brittle, where if you just touch it a little bit, you'll ding off the antenna or whatever it is. So you're going to need a little cleanup area because you're going to use isopropyl alcohol or some other cleaning material to wipe that liquid resin off the print. And you need to spend a little bit of money to get the supplies and some of the materials you're going to need to do that. You also need to obviously consider about electrical use and heating that room so that the printer is warm enough so that you don't have problems with resin. So I'm saying, roughly FDM, maybe $300 to get started. That was my alarm to stop talking. With SLA, you're looking at about $600 to get started. Some people can argue that you don't really need that much, but if you're going to do it right, you're going to need to spend a little bit of cash. Okay, time. Your printing time is going to vary anywhere from an hour for a print up to maybe 6 hours. I know people that have printed things for 24 hours or 72 hours. I don't like to do that because I'm kind of a nervous person when it comes to waiting for my prints to come out, and I've got a little camera set up in front of my printers, so when I'm out I can look it up and see if my prints are still working. It can be a little bit much sometimes. Let's see here. Also consider the time it's going to take to add all the supports that you're going to need for prints that are complicated, but also the amount of time it's going to take to clean the printers. When you sit down with a resin printer, it's like 5 minutes to get it all ready, and then you've got another 5 or 10 minutes of cleaning it up, wiping off the print, putting it in this bucket of alcohol, then clipping off the little edges. Like, there's a lot of work to do. So when somebody asks me, hey Dave, can you print this thing for me? I say, well, yeah, of course I can. It's $25. And they'll look at me for a second and say, $25? It's only going to take, it's like $3 for this thing. Yeah, but I have to add the supports, I have to get the printer ready, I got to take it off the printer, I got to clean it off, I got to clip all the stuff out. So I got to charge you at least 10, 15 bucks for my time, right? So consider that when you're starting to put stuff together. For us, doing our own work, not a big deal, right? Because we're just going to keep doing it. It doesn't matter how much time it takes. But those are all factors you need to take into account when you're starting to do this kind of thing. Also, you may need to fix your printer every once in a while because something gets broken or is dirty. Usually you can do it yourself, but sometimes you got to send it back, and then you're shut down for a month. That's why I have 2 of each printer that I run. Okay, safety, gloves and masks. I'm not going to get into this too much, but I'm the kind of person that feels it's better to be safe than sorry. So when you're printing with resin, you should wear a mask. If you have a printer set up at your desk, you should probably have a vent that is exhausting those fumes outside. Okay, it's not enough to have a fan that blows it into the hallway. You really want to get it out of your house. There are some fumes from these that we can't smell them. They put, sort of like they do with gas, they put some odor in there so you can sort of smell the resin, but there are a lot of things in there that we don't know yet. If anybody, there's a YouTube channel called Goobertown Hobbies. Goobertown Hobbies. And he does a great job. He's a couple of videos where he takes 3D printing resins. He's a chemical engineer. And he breaks down the chemistry of the resins and talks about what's safe and what's not safe. I would check that out because we're kind of running out of time here. But the bottom line is, if you're printing with filament, FDM style printing, that material can be thrown in the trash. You don't have to worry about it. If you're doing resin printing though, that liquid resin cannot be thrown in the trash. It cannot be put down the drain. It's a dangerous chemical and it needs to be handled properly. That's why I wear gloves. And when I'm done printing and everything's all cleaned up, I take my garbage, whether it's pieces that I clipped off the print or some liquid resin I had to clean up from the table that's spilled, and I put that all in a bag, tie it up, and that goes in a box, and I take that to the dump. Any liquid resin that you have in the container that you haven't printed, seal that up, take it to the dump, okay? You don't want to throw this stuff in the trash. You don't want to put it down the drain. It's just not good for the environment or good for you. Let's see here. Again, the caveat is check your local laws, because I don't know what the laws are where you live, and they probably are pretty similar, though, to where I live, which is don't throw resin down the drain. So, failures. Everybody's going to have failures. This was supposed to be sort of the fun part of the presentation, but we're running out of time here. So, you can see all kinds of problems arise, whether it's bed leveling, which is sort of the biggest problem that most FDM printers have, where the bed has to be perfectly level to the plate, okay? If the plate is off a little bit and that thing comes down to print, weird stuff is going to happen, okay? Little stringy things are going to start coming off. Or even with resin printing. You know, that image in the lower middle section there, that was supposed to be a set of dice. Oops. Okay? So, you know, the one in the upper right corner, somebody sent me a model of an airplane. They're like, oh, I got this awesome 3D model of an airplane. I didn't ask where they got it from. But I was under the impression that it was a good model. It turns out it was a great model, lots of detail, but it was made for rendering. It was made for like a video game. It wasn't made for 3D printing. So it needed to be converted, which I, at the time, was one of the first things I printed. I didn't realize that this wasn't going to work. And so when we printed it, the wings didn't print properly because they were too thin. They were accurate for the scale of the plane, but in order for some things to print properly, you got to blow them up in size. When I print a tank for somebody, like the little gun barrels that stick out, I double the size of those. It's not accurate, but it prints, and that's what people want. So here is a list of some of the printers, and again, you can download this presentation if you want to get this list. You don't have to look at it right now. But basically, I'm listing FDM and SLA printers. All of those FDM printers get really good marks, and the same thing with the SLAs. And to be honest with you, most of those SLA printers are the exact same thing. Okay? They use a lot of the same parts from the same manufacturers. They're just put together a little differently. They put a different color hood on the top, it's orange or red or green, but they all do pretty much the same thing. You can use different resins in these printers. So some companies just make resin. They're guaranteed to work in whatever printer you put it in, because it's just based on the wavelength of the light that all those printers are projecting out. So where do you get the files from? You can go to Thingiverse to download files. There's a number of other places like Free3D, TurboSquid, Sketchfab. They've all got tons of stuff out there. Kickstarters, that's another one where you're going to hear 3D Kickstarters there's a lot of them. Whether it's miniatures, terrain, I saw some great houses the other day that somebody was working on. There's a lot out there. Now, obviously, you're paying for that. It's not like the free stuff. But you may find something you really like, something that's perfect for your game. Some Kickstarters have a retail option where you can print those models and sell them. But if you're going to use it in your game for a game design, you're going to want to ask the creator, or work out a deal with them or an agreement where you can use their model in your game when you publish it somewhere else. You don't want to use anybody's free 3D model in your game and not give them credit or money or whatever, because they can come back to you then and sue you for using that model without proper authorization and putting their name in there. So just something to keep in mind. Software, like I said, there's some free software out there that you can get. Blender, SketchUp, Tinkercad, FreeCAD. There's a lot. And they're pretty easy to pick up. Again, my background is all about CAD, so it was easy for me. But even people that don't know it very well can pick it up because the concepts are pretty simple. And for us, as game designers, a lot of what we do is real simple. Are we at the end here? All right. So, if you have other questions, feel free to come and talk to me about them. There's just a few more slides here that show some of the various places that you can go to download or buy miniatures, whether it's Shapeways. Hubs is a great one where you go to their website, you tell them what you have, and they will find someone with a 3D printer to print it for you. And the prices are pretty good. You can go to places like Hero Forge and create your own miniatures. This is one that I created. It's a battle chef with some knives on his hand and some magic spices in his other hand. My Mini Factory actually has a tabletop section where you can download miniatures or buy miniatures. And then you've got Thingiverse. As far as getting help, I would go to Facebook, Instagram, YouTube, any of those things. You're gonna be able to find help. You're gonna find people that have been doing this for a while that can answer some of the questions that you have. Okay, so that went a little bit longer than I thought it would because I love talking. Question in the back.
Yeah, I just wanted to point out a lot of public libraries have 3D printers that you can access for free or almost free. There's a low-end fused deposition modeling one, but they're...
That's awesome. Yeah, I have not tried to do that. I live in kind of a small town, so it might be a while before they have like an LCD panel. But they don't have a 3D printer as far as I know, but they do have it at the high school, I believe. So, yeah, there's... Yeah. Exactly. Other questions? Fire away. Yes, sir.
There's a company in Stoughton called Virtual Foundry that's been doing some work with centrifugal metal filaments.
Oh, really?
If you've experimented with that at all.
I have not. But I did look at printing some stuff on Shapeways in metal. I don't know what technology they use, if that was SLS, like laser sintering or whatever. But no, I don't have a lot of experience with that at this point. But it's out there, and the stuff looks great.
Yeah,
somebody did a 3D printed, oh, what was it? It was like a cap for like a bottle or something. And the detail, I mean, they buffed it up, so it was super shiny and it just looked really cool. So, all right, other questions? Yes?
So if you have parts where you want to fit other game pieces into it, like the dice in the top center
Yeah.
wire, do you have any advice for calculating like how much tolerance to give it to get a good fit?
Yeah, usually it depends on two things. It depends on the printer, the type of printer, and the material that you're using. And then for me, like, I'll get the calipers out and I'll measure it with the calipers, and then I'll maybe give it an extra 0.05 millimeters, like 50 microns to maybe 100 microns, you know, so not more than a millimeter really is needed. Now, that's different than if you're keying things together. You know, like if you have an object that's made of multiple parts and you're trying to fit those pieces together, you really need to be more careful in measuring, because you want a tighter fit than if you're doing something loose that you want to easily take in and out. You know, so if you're usually with the printer, it will say what the tolerances are on it, and that will give you a rough idea of what you can do. You know, we got to wrap it up.
Yeah, we gotta be done.
All right, so somebody else is going to be presenting, so we got to go.
I am, but I'm really enjoying
Oh, it's you. Okay. Well, no. So if you guys want to, as we break here and I wrap up my stuff, we got a little bit of time. If you want to come and look at some of the prints up here, you can see some of the different types of printing and some of the objects that we've created. Give you a little better idea of what we've done. Thank you very much, and thanks for putting up with my lengthy discussion.